Hello, everyone, and welcome to another episode of OpenObservability Talks. I'm your host, Dotan Horvitz, and here at OpenObservability Talks, we talk about everything DevOps, observability, and open source. For those following the episodes, you probably know that our sponsors are logs.io, the cloud-native observability platform that brings your metrics, logs, and traces to one SaaS platform, and it's based on open source. So thank you very much, logs.io, for sponsoring this podcast. And for you joining the live stream on YouTube or Twitch, feel free to share questions or in comments on the chat. Interesting things we'll try and incorporate in the fireside chat. So it makes things much more interesting. So do go ahead and do that. And with that, let's move on to today's episode. And today we'll talk about what it takes to build observability in web scale companies. And my guest is someone who has done just that at Twitter, Pinterest, and currently is a senior staff software engineer and a tech lead for observability at Slack. And with that, I'd like to invite Suman Karumuri to join me. Hey, Suman, good morning.
Hey, Dotan, how are you? Good morning.
I'm fine. Thank you for joining me from the Pacific Coast. How's it going there?
It's good. Nice day. Very warm.
Great. So, Suman, I think one of the fascinating things is that you've done so much in so many companies around observability. So maybe you can share with us a bit about yourself and your background with observability.
Sure. Hi, everyone. My name is Suman. I'm currently a senior staff software engineer at Slack. I currently lead the observability team and also the performance initiatives at Slack. So my journey here has been quite a long one. Currently, I'm at Slack, and at Slack we built a tracing system from scratch, and I also called Slack Trace, and I also worked on log search here. Before Slack, I was at Pinterest, where we built a tracing system called Pintrace, and before that, I was at Twitter, where I was a tech lead for Zipkin. We built an in-house log set system based on Loglens, and I was also played a little part in authoring the open tracing spec. My passion is basically building these like large scale observability systems, and I build them more out of necessity than joy. But yeah.
Yeah, I think we'll talk much about the necessities or these gaps with existing solutions on this episode. I think you're bringing a very unique point of view about, at least for the web scale type of companies, what the challenges are with existing solutions. But before we go into the technical solutions, I'd like to talk about the organizational aspects, because talking about companies such as Slack and Twitter and Pinterest, these are web scale companies, not just in the volume of traffic and users, but also in the size of the organizations. And I'm curious, in such large organizations, who owns observability and how is that constructed within the organization? Because I've been hearing I've been working with small and medium organizations, also with enterprises, but then you hear the challenges in the large organizations, the discussions about shared services, consolidation versus distribution. So I'm wondering how you view the large-scale type of observability organization.
Yeah, at our scale, I think there is always has been an observability team. And at even larger scales, there is within the observability team, there is a log search team, there is a metrics team, and there is a tracing team. So yeah, I think most of the models, to borrow your phrasing, are centralized. And the reason they are centralized is at web scale, or even at a reasonable scale, most observability systems are like running specialized databases. And to run these specialized databases, you need to know some things about the data model, some things about the query model, and some things about how people are accessing the system, a few things about where the weak spots of these systems are. And also, observability has grown so big now that a single general engineer cannot just keep all the things in their head and like deal with it, right? So observability is a specialization, and I think increasingly, just like you have database admins or a database team, I think observability is like that for the modern times. A
I see.
centralized team that specializes in observability, that has two things: in maintain the infrastructure and also help your engineers, teach your engineers how to use observability and make sure they're following the best practices, and also deliver business value at the same time.
So you say both in terms of choosing, I guess, the technical stack or developing it in-house in case that no off-the-shelf solution is there, but also you say about maintaining it and also being the center of knowledge to disseminate it across the engineering organization. Is that correct?
Yes, exactly.
And there's another aspect that's very interesting about these, again, in large organizations, is about standardizing the formats. Because, if
Mhm.
each team will decide on its own logging format or labeling for metrics or something like that, then,
Yeah.
cross-referencing events across teams, across microservices, across boundaries will become much more challenging. So do you see that also on your end, on the
Yeah,
standardization side?
exactly. So you're absolutely right. Like, I think one of the key parts an observability team plays is actually helping all the teams standardize. So in middle of an incident, uh, we are not asking where are logs for this team versus why are logs for this team in a different system versus. Like, if you don't standardize, right, one team will do what's best for that team, but they're not thinking what's best for the company, or what's the best solution during an incident,
Yeah,
right? And also, they're also not thinking, hey, what's the best, most cost effective solution for Slack, right?
yeah.
Or your company. So I think this is like standardized, like a lot of things get bundled under standardization, but I think yeah, you can say that the observability team is guiding engineers towards standardization so they can reduce the MTTR during an incident while managing the costs.
And that's ultimately the bottom line, because when you
Mhm.
when you don't create silos where each one has its own standard or its own conventions for labeling and for metadata and things like that,
Exactly.
then the cross organizational type of incident investigation becomes a nightmare, because you need to understand that service underscore ID here maps to service ID with a capital I or whatever. It starts
Yeah,
mapping all sorts of
exactly.
weird conventions and things like that.
Yeah, you actually get something a little bit worse, which is uh, people don't realize how complex these monitoring stacks are too. So you'll have multiple monitoring stacks in the company too.
That's true. And I guess there's another dimension that's interesting, which is the compliance side of things, like
Mhm.
GDPR compliance and things like that. That, first of all, large organizations are much more exposed and sensitive to these things. And on the other end, these are cross-cutting concerns that need to apply equally across the organization, irrespective of the types of data storage or usage, because this is a compliance issue. So I guess this is also a way to enforce that across the organization, right?
Yeah, exactly. So I think one of the larger transitions, I think increasingly the databases are becoming a little bit more commoditized in the observability space. Previously, they needed more love and care. These days, not so much.
Yeah.
But the scale is also increasing, and with the scale, what people are doing is there is no one size fits all database for all observability use cases. So for some logs, they're just for archival reasons. You just like shove them to S3. Some logs, you want to search them in real time, and then you want to ensure that specific fields exist, so you get them during an incident. And for some logs, you want to do some complex analytics, so you want to send them to the data warehouse. And increasingly, the observability teams are actually becoming more and more a pipeline management team as well. They have to manage like these telemetry pipelines, and these telemetry pipelines also have to enforce things like GDPR compliance, make sure people are not logging like security tokens in the logs, filtering out PII. make sure that the data is sent. Like, let's say you can put it on S3, but maybe legal is not happy about you sending logs out of your data center. Like, there are places where that's not the case. So yeah, like telemetry pipeline management is also a big part of what observability team does, in addition to enforcing standards. And also, we are contributing a chapter on telemetry pipeline management to the upcoming book on observability engineering by Charity Majors and Liz Fong Jones. Please check it out when it comes out.
Yeah, it's actually a very nice, resource that all of the community will probably cherish. A book dedicated to observability. Finally, it makes the
Yeah.
front page, and getting people such as yourself, experts, contributing chapters beyond obviously Charity Majors and Liz, who are experts from Honeycomb. That makes it very interesting. So it's not out yet, but the preview I think is there, and I'll share the link with the audience. So definitely check it out. And thanks for contributing the chapter for the community.
Thank you.
So what I'd like to discuss maybe is the gaps, because you talked about the need that you found in actually developing in-house logging system at Twitter, and then a tracing system in Pinterest, and now in Slack and so on. It's not because you don't know what's out there. I know, and I can testify that you know better than many of us the things that are out there, and still you found them not suitable enough for the needs and the scale that you needed. So I'd like to go over that, but let's do that according to the maybe to the pillars, and start with the logs. So logging, metrics, and traces, that are the common pillars. We can challenge that as well. You and I talked about maybe logs and traces should be one, and maybe additional pillar with the continuous profiling, but
Yeah.
that's a whole separate discussion. But if we stick to the traditional conceptual model of logs, metrics, and traces, then let's talk a bit maybe about metrics first, and maybe what gaps did you find in the current way that we handle metrics?
Yeah, I mean, great questions. So, the standard for metrics is Prometheus, but actually, if you think about it, metrics is the most fragmented uh, system of all the places. For example, I worked at Amazon. Amazon that has their own metric system. I worked at Facebook. Facebook has their own. I worked at Twitter. Twitter has their own. And I worked at Pinterest, which used OpenTSDB, and then it didn't scale. So I rewrote the metric system at Pinterest as well. And then at Slack, we use Prometheus. And then even like within Prometheus, like everyone uses, like a lot of people at scale who use Prometheus actually for Prometheus, because it has a lot of features that we don't need. So the thing is, metrics is very fragmented. And the reason the systems are fragmented is, for a long time, the model of metrics has not been standardized. But with Prometheus and Google's muscle behind it, Prometheus is kind of standardized the data formats and the query formats for metrics. And with this standardization came a bunch of good things, which is like we have built like several metric systems like Cortex or Victoria Metrics or Thanos or all of those things, right? But the still one thing that's still lacking in the metric space is there is no single solution that actually works. That's a good distributed database in metrics. The best one we have right now, in some sense, is Prometheus, because if it doesn't scale, you just launch more nodes, and it kind of just like basically, thanks to God and Moore, right? With Moore law, we can actually scale vertically and also horizontally very easily. Whereas existing systems are good, but they're still very hard to manage. They sacrifice data, which creates a lot of problems at scale. With these metric systems also, because they sacrifice consistency, you cannot add any automation in front of it. For example, when I was working at Twitter or Facebook or Google, there is an automated system that used to automatically look at metrics and like kill instances and things like that. I can't take anything in open source today, put automation in front of it, and expect it to work well. Because the data consistency guarantees are not there. If you put automation in front of those systems, because automation systems are not very smart, they end up doing the wrong things. Uh, Yeah, and also they don't scale very well, like how many metrics they ingest, how many timestamps they ingest. That's one of the reasons. I think there's a lot of room for improvement there. We wrote a paper called Mac, which builds a new metric storage engine, for example, that's better than Prometheus. So I think there's a lot of room for improvement in metrics space.
So I think that the paper is very interesting. You just released that, I think, a week or so ago. It's very fresh and
Yeah.
very exciting. You're going to you introduced it in Mac, and it's called a pluggable metric storage engine for the age of observability. It was accepted by the CIDR now. And I saw that, and I was pretty impressed without understanding all the details. Definitely, just seeing the end results, talking about 10x more write throughput and 3 times read throughput than Prometheus was. For me, it was very exciting and willing to see. So it's just a research paper, right? But
Yeah, it
maybe
is.
having a POC later down the road. But what is the main takeaways from that for us that are not so into the details of the
Sure.
database implementations?
Yeah, okay. I'll give you a high level summary, but you should refer to the paper for like the nitty gritty details and the limitations and all of that because it's a podcast. I don't want to get into too many details. So, for the first thing with any metrics storage engine, right? Prometheus, it takes the metrics you give it, just writes it to the storage engine directly. One of the things we actually do is we do tired storage. So, we have a staged ingestion pipeline. So, what happens is you take the metrics, write them to disk, uncompressed, and then compress them after you reach like a few data points and things like that. Because of this like staged execution, one of the advantages we get is Prometheus actually has a fixed compression mechanism. You can change the compression mechanism after, you have to pick it first. But because we have this staged ingestion mechanism, you can pick a compression mechanism that is more suitable to the data. You know, so that's one reason why this system is a little bit better because sometimes Prometheus actually explodes when you give it the wrong type of data, right? High cardinality data, for example.
Yeah.
The other reason this system is actually better is there's a lot of duplication of labels and things like that in Prometheus when you are ingesting the data. We actually ingest the data in a as a multi values. So if you have common labels, we can ingest multi values in parallel. That actually improves our like write throughput quite a bit. And also, the third advantage compared to Prometheus is we write the data directly to disk because of that staged compression. So you can actually ingest the data at the disk at as fast as disk can read it. That's one advantage. The second advantage you have is Prometheus has one of these big problems where, let's say Prometheus nodes restarts, it has to reprocess the wall, the write ahead log, and to rebuild the data, and that takes like for us it takes like tens of minutes, and that kind of like kills any P99 metric you want to have. But because we write directly to disk, our recoveries are much faster. So at least in these three high level things, this engine is better, both from an operational perspective and a performance perspective compared to like existing engines.
Nice. So you get the improvement both on the write when you do the parallel writing with the optimization. You get the read, obviously, from the also the size with the compression that
Mhm.
is more suitable based on the data, and the recovery times are faster. So I think
Yeah.
it's really exciting. And I posted on the for the ones on the live stream just now. I posted the links, and I will also post them for the podcast listeners on the episode notes. So very fascinating research paper. And you said that you may release some sort of an open source proof of
Yeah.
concept of that research paper, right?
Yeah. We have an open source thing in the works, so we'll probably release a fork at some point. Yeah.
So let me know, and we'll share that with the community as soon as it's there with the Open Observability community. That'd be a great follow-up to this
Sure.
episode, but really fascinating. So I think you touched upon several limitations, both on the general approach of metrics and also on the common patterns introduced by Prometheus itself, which is really a de facto standard. So which led you to develop the in-house solution. And maybe we can touch about logs now. We'll go back to metrics later, but just to cover the grounds with the gaps analysis that we're making. So
Mm-hmm.
logging also has its share of limitations. With all due respect, although it's been around for so long, we still have quite a bit of challenge. And I know that you've done, as you said, you rewrote or wrote from scratch the log analytics at Twitter, and then you found yourself doing it a few other times. So let's talk about log analytics pipelines. What led you? I think you started from the Elk Stack back then, right? So what
Yeah.
maybe gaps you found in Elk Stack, and what drove you to do the in-house implementation?
Yeah, so my first introduction to log search actually started at Twitter when I was at Twitter, and we used to use Elasticsearch back then. Back then, the story was there was like a hack week, and somebody just like installed Elasticsearch and then said, "Hey, use it." And then in 2 months, we were sending so many logs to it that we needed a team to own it, and then for good or bad, my team ended up being the team that owned log search. And back then, one of the problems with Elasticsearch, this was like way back in the day, and then Elasticsearch was not as solid as it is to be now, and it used to just go down for days. Sometimes, like we used to manage about like, I mean, these days these numbers are not that big, but back then we used to manage about 50 to 100 terabytes of data on Elasticsearch, and then it used to. There were incidents where Elasticsearch would go down almost every 2 or 3 days, or sometimes when it goes down it would corrupt the entire data set and things like that. So I mean, we did this for 6 months, and at some point we decided, hey, like this is just too much work. It's actually easier to rewrite Elasticsearch, and then that's exactly what we did. We built a system called Loglins, and then we rewrote Elasticsearch. And by the time I left, Loglins was managing about 2 petabytes of data,
Wow.
log data in the system. And it was a very cost effective system. Like also the cost with log search, the cost is also very high. So this was back in the day when like tired storage was not as popular, and then we implemented tired storage in log search, right?
Yeah.
Going forward, I did some ES stuff at Pinterest. Afterwards, I managed ES at Slack, and we run Elasticsearch at a decent scale at Slack. We manage about a petabyte of data. And what we actually found is for a week of data, even at that scale, Elasticsearch is actually not reliable, because we find like a lot of issues. We find issues like a single Elasticsearch node goes down and the ingestion stops. The entire ingestion stops. Or field conflicts are a major issue for us. For example, like because of field conflicts,
In the
because we have,
types, like the field typing.
yeah, field typing. For example, if one user has an account ID as a string and another user has an account ID as an int,
Ouch.
only
No,
one
no,
user
yeah.
logs makes through. And because of index rotation and things like that, whose logs make through
Yeah.
changes based on every 20 minutes or 30 minutes, or like whatever that time is. And this actually creates like a lot of usability issues for us. Also, it's kind of surprising that you can say that, hey, like for small scales, Elasticsearch works, right? But it actually introduces a different problem. Like when you actually have one Elasticsearch cluster for a microservice or some set of services, right? At our scale, you end up managing like 60 to 70 Elasticsearch clusters. And my Slack is not even microservice heavy.
Yeah.
And so now you need to write software to manage Elasticsearch automation. So so the multi-tenancy and isolation is just too much work for us, and it's like not like valuable work. And also Elasticsearch just started doing tired storage, and it's not that great yet. I mean, I'm pretty sure like you wait a year, it'll be much better. But so they don't have like it costs too much. We recently disabled full text search in our cluster, in some of our clusters, because of cost, but people actually need it. Like most people think that they don't need it, but uh, the, but if you once you remove it, you'll know how often you needed it.
Yeah.
Because there is no replacement for, as you said, right? One person puts a service ID in the service ID field. For another person, it's just an ID field, right? And then how do you search those logs? Like you just have the service ID and you have to search like link these things across systems in an incident, or like to do some analysis, and you can't go back and fix that,
Yeah, the hell of unstructuring is the worst in logging. I think that's the place where
Yeah,
the
yeah,
mess is
that is
biggest,
true.
and that's why the free full text search is so needed there, because
Yeah.
it's very hard to enforce a structure for
Mhm.
the logging that makes it. And you gave a good point there with the log storms also. The
Yeah.
when with the log
Oh yeah, that's the
logging and
big one.
monitoring, when when something crashes, then suddenly you get logging all
Yeah,
over the place because everything crashes, and you get from the database and from the networking and from the node
exactly.
and from everything. And then the question is
Yeah.
how the system managed that. What did you find with Elasticsearch in your case?
So yeah, that's the other big problem for us. Like log storms are a big problem. So the only way to fix the log storms today is you scale up the cluster to some amount that you can actually afford. Generally, our log storms are bigger than that. So and then you fall behind, right? And
Yeah.
you just accept that cost. And people don't like that. Like people don't like when, like, it's like driving a car on the highway, but the speed you're seeing is like from 10 minutes ago. That's not helpful. If you want to do some, like, if you want to see if you're over the speed limit or not, and it costs a lot. So this is like one of the reasons we are actually trying to replace at least Elasticsearch with an in-house solution based on Lucene. Because what we found is, like, there are a lot of log set solutions out there. We are calling our solution CalDB. There are a lot
That's
of
the
log set.
solution in Slack, right? Let's just not to confuse the audience. You built a logging system back at Twitter, but now you're fast forwarding to today. Actually, that
Yeah.
you're. I think you even haven't published it publicly. Maybe this is the first time for the audience to actually hear about CalDB. You're going to publish something public about the new system, right?
Yes, it's still under development right now. We are very close to putting it in production. So this is the first time. I mean, like, I'm talking about CalDB publicly. So yeah, there are a lot of systems out there, but most of the systems assume that Elasticsearch is expensive because Lucene is expensive. That's actually not quite true. Lucene actually is a very good storage engine, and the architecture we had for Loglins works really well even today. Actually, it works well, much better now than it was before. So CalDB is pretty much like a system very similar to Loglins. We're taking the lessons from Loglins, we're taking the lessons from Elasticsearch, and then building CalDB. And in this, it's cloud native logs. It's a cloud native Lucene based indexing system. And then we actually want to handle log storms better. For example, if you're getting like 10x the amount of logs than your baseline, because it's January 1st and everybody just decided to log in, sorry, January, like the first day of year.
Yeah,
Or
Workday. Yeah,
yeah, or some big customer decides to run like a background job to migrate their because there is a merger and they migrate their log messages from one system to another. Not like a ton of log messages and you have no control over when those things happen. So
yeah.
what we actually do is we built the system that automatically scales by the logging volume
Nice.
elastically, as opposed to you having to pre-provision the system. And also, managing Elasticsearch is very painful because it doesn't run on Kubernetes or anything like that. So we run on Kubernetes to make operations easier. We also try to handle field conflicts automatically. So we ingest the data with field conflicts, and then we try to resolve them on read, uh,
Nice.
as opposed to on write, because it's easier to change your query to read the logs than it is to get the drop data, right?
Yeah.
So that's the other thing. And we also have interesting solutions for multi-tenancy instead of running 100 clusters. So one of the biggest reasons for multi-tenancy is you want to isolate the workloads, right? You want to say this set of machines are not affected by the query from this other user is running. And Elasticsearch today, you can host multiple indexes on the same node, but there is no isolation. What CalDB does, it provides you multi-tenancy plus isolation. So that's one of the features in CalDB that reduces our operational overhead for the logs. And we also do not have single points of failure. At least the system is designed so that if one node goes down, only the data for that node is delayed. Not like if you have n nodes and if one node goes down, only one nth of the data is delayed, as opposed to all your data is
Yeah.
delayed. you know. And also when the data is delayed, it actually makes the problem worse, because you have a log storm, you're behind, and then the system is under pressure, it fails, now you're further behind. So that's one of the reasons why we had to redesign these systems, and not like we just couldn't take existing systems because they were not designed with these failure cases in mind.
That's interesting, actually. And on the other end, it's very interesting to hear that you still find the basic Lucene library. By the way, for the audience who doesn't know, this is the Java library that's Apache Lucene under the Apache Foundation, on which Elasticsearch is based. So you still see that the foundations of Lucene are very valid and actually are in many ways enable much more than what Elasticsearch has made out of it. So it's important to distinguish between the baseline Lucene and the wrapper that or the implementation that Elasticsearch offers. And by the way, there was a very interesting article that I read a few months ago by a company that used it for search purposes, enterprise search, not logging, but still they found the same solution. They actually found that implementing their own, it's company called Yelp, and
Yeah.
they, instead of implementing, going with Elasticsearch, they decide to implement on top of Lucene, and very interesting. We also have a comment here from the audience saying that regarding your point on the automation and operation, that this is something that has been in extensive work at OpenSearch. OpenSearch, for those who don't know, is started as a fork of Elasticsearch and Kibana before their relicensing to a non-open source license, and now it's an independent project, and lots of activity there. And part of that is on the operational side, things that were not available on Elasticsearch, and now they can implement in OpenSearch. One of them is operator. We mentioned the Kubernetes. So, but admittedly, even there, lots of work is needed to run it at scale. So thanks for the comment there. And sounds like your CalDB is going to be a fascinating another fascinating project. Are you considering sharing that as a form of open source or some sort
Yeah,
of?
it'll definitely be open source. Yeah, because one of the things I don't think we have open sourced the loglet system, and I think back then I thought it was such an obvious idea that nobody would, like, somebody would just build it better than I would. But it's been like 7 years and nobody did. So at least this time I want to open source CalDB
Nice,
for
nice.
sure.
So we touched upon the gaps in the logging systems, and specifically with Elasticsearch was the leading open source there in the industry. And the third pillar, tracing system, the youngest, but still with quite some gaps. And you've been with a lot of experience there, even from your Twitter days. You've been playing around with Zipkin. You've been contributing to open tracing. Just to name a few, and you've built at Pinterest the Pintrace homegrown solution, and now at Slack with SlackTrace. So I won't bother you with all the background there, but maybe if you can summarize all your years of experience, both on the open source available solutions, products, APM,
Yeah.
whatever you've touched, and maybe what are your learnings and limitations, probably the ones that led you to develop SlackTrace.
Sure. Yeah. So, yeah, as you said, right, I was the tech lead for Zipkin. Back then, there was nothing like Zipkin. So Zipkin is Zipkin is the only tracing solution back then. And then I worked on Zipkin, and then the next thing that came up was when I went to Pinterest, we wanted to build a distributed tracing system there. So I started Pintrace. When we started Pintrace, there was no open tracing as a thing did not exist. So I was working with Ben and all these people, and then we decided. Ben suggested that
Ben Ziegelman, whoever
yeah,
doesn't know, the leaders in
Lightstep.
open tracing, Lightstep, and obviously in open tracing. And maybe a word for the audience who doesn't know open tracing. Do you want to say a quick word just for the context?
Yeah, open tracing is basically rebranded open telemetry. Or the first version of open telemetry. So open tracing and Census, Google Census merged to become open telemetry. So
But open tracing essentially was an attempt to standardize the API side. It's not the
yes,
implementation, but the API side of how
the,
to, in your code, to write it
Mhm.
in a vendor agnostic way, to
yeah,
expose spans and
expose
trace
spans
data
and
from the application code into some sort of a backend in a neutral way? Just to very
Yes,
briefly
that's
summarize, now
exactly it.
instead it's merged into Open Telemetry together with Open Sensor. So just for the context of the audience, so back then Open Tracing wasn't in existence, and you needed to develop
Yeah.
Pintrace.
Pinterest. And then, so I wrote the first open tracing library at Pinterest that basically we took the feedback from that, put it in the spec to improve upon the API. And I had experience doing the Java API at Twitter and the Scala API, and then the Python API at Pinterest. So that's I was able to like add my 2 cents, so to speak, to the doc
Nice,
from
nice.
that experience. And yeah, once we came to Slack, we wanted to do tracing here. But one of the things I've seen with the tracing systems in the past is the ROI of tracing. Like it was too much work to add tracing, end-to-end tracing everywhere, and but the return on investment was not there because it was a lot of work. It was a lot of work to keep up the system and then trace the system. When it worked really well, right? For the problems of like understanding what's going on, and like if you have latencies, where the latencies are, it worked really well. But the thing with the tracing systems is you deploy a tracing system, you'll find like these 5 things that added a lot of value that you couldn't have found otherwise. You'll get those, and then after that, it's like the next year you'll find 5 more. So the first month is like really good, and then the next year it's like 5 more, and it kind of like is a depreciating return on investment. And but you have to do more and more work as more systems come to keep that tracing graph complete and all of that. So the ROI is low. And the other problem with tracing is today tracing ties you to the request response path more or less. So tracing works really well in the backend systems, but it doesn't really work well on the clients or other places that you can use. And the third thing we saw was it's more valuable if you have more microservices thing, like at least the existing tracing systems, but not so much if you have a little bit more monolith. The more important part is I after using these traces, I found there are a lot more use cases for tracing that are not covered by the existing tracing systems or like the vendors, and that's why we actually built Slack Trace.
Interesting. So I think, by the way, your point about the low ROI, surprisingly enough, is still there in a way. I can see that
Yeah,
many people, although there's been a lot of activity to do auto instrumentation libraries and agents and things like that, you still see that the effort, the barrier to entry, the instrumentation is painful. It's not frictionless by any means.
yeah,
And because tracing, unlike logs, is not something that any other developer uses, then people start asking, is that investment worth the while, the maintenance?
yeah,
Because you said new microservices, new systems, each one you need to make sure that it's there. Otherwise, it breaks tracing
yeah,
is all built on the context propagation. You put
yeah.
in one system and that one system hasn't propagated the HTTP headers,
Headers.
P3
Then
format, whatever, W3C, then you got broken trace, and all your previous work is also worthless. So
yeah,
I
exactly.
think, and the question keeps on rising. So is the investment worth your while? And I've been in these discussions
Yeah,
over and over, and I've been trying to preach, obviously, the values, but it's
yeah,
a valid point, and very interesting to see how you at Slack address that, because I know that your part of your tracing 2.0 is actually an attempt
yeah.
to get it much more easygoing and seamless.
Yeah, so at Slack, I mean, for lack of a better term, we are calling it Tracing 2.0, which is like a better tracing system. And what we actually did was we actually broke down tracing into 2 parts. The first part is the general idea of producing a trace and querying it is actually good, but the current tools don't let you query the exact trace data in its raw form. You actually just have a UI and then you can only do a limited set of queries, right? But what we wanted to do was open up that format so you can actually query traces like raw data like you would do with logs. And to do that, what we actually do is we wanted to make traces easy to consume, right? And to make traces easy to consume, so this is how we increase the value out of traces. To make traces easy to consume, we put them in Elasticsearch so you can do like analytics and Elasticsearch queries on them. And we also put them in the data warehouse where you can actually run SQL queries on those things to get
Interesting.
additional insights. So you can actually say, hey, you can actually construct a query like, what percentage of the time is spent in MySQL queries, or rather, let me put it this way: is my overall endpoint slower now because of MySQL, because of my database? You can ask interesting queries like that. Like in the existing tracing systems, that data exists, but you can't formulate a query because the data format that they have is very complex, the open telemetry format. So
Yeah.
we take those spans and convert them to a simpler span event format, and we ingest those span event format in the data warehouse, which are easier to consume and process.
That's
So
interesting because it's a pattern that you ingest the same data, but then you store it in different ways to enable different types of queries. I think this is something that
exactly.
is very interesting, even beyond just traces. If you look at other types of telemetry, a way to merge
Mhm.
the different telemetry together to query. Yeah, that's very interesting.
Exactly. Yeah. And the side effect of this is these traces are also easier to produce because the span event format is easier to produce. We have libraries now which directly produce these span events without tracing. And what has this enabled us? This helped us take the tracing and put it in our clients. Like, for example, if you use a Slack client today, you can actually, there are like multiple traces running in the Slack client, in all our Slack clients, and we have end-to-end tracing. And the mobile frameworks or like JavaScript frameworks are not very amenable to tracing. So our system is actually better than the existing ways to trace those systems. And further, we also separated this notion of a trace as one request, one response. This actually complicates the production of traces. So we actually have custom tracers where you can have multiple tracers active in the same request at the same time. You can read more about it in our blog post. I don't think I have enough time to go into all of those nitty gritty. But the
Yeah.
advantage of these things overall is we actually apply tracing to our CI/CD pipeline. There is a blog post on the Slack engineering blog where you can see how tracing is used to optimize our CI/CD pipelines, our build pipelines, and we even now use tracing for modeling business funnels. Like
Wow.
if you have a user journey and when people are moving through those funnels, right, we actually use traces to model them now. uh,
That's fascinating. I actually hosted here in the on the podcast on Open Observability Talks, Yuri Shkuro, who is the
mhm.
founder and the man behind the person behind Jaeger
Very
and behind also Open Tracing you mentioned, and
yeah.
Open Telemetry is involved, and many other activities. Is currently at Facebook, and one of the things that we've discussed is actually that tracing as an underlying mechanism, as the
Exactly.
plumbing, irrespective of
Wow.
the IT observability, is actually once you have the
Yeah,
plumbing in place and you can propagate context, you can then do whichever payload you want. And the payload can
exactly.
actually be one that can serve FinOps use cases or
Mhm.
BizOps use cases
Exactly.
or compliance use cases or many other
Exactly.
things, sort of because you just propagate the tenant
Mhm.
ID, the account ID, the I don't know other types down to the back
Yeah.
end where you can actually apply all sorts of
Mhm.
logic and queries that map backend processes back to, let's call it, business entities or legal entities
Yeah.
or map it to business units or to tenants, and it's really amazing. So it's something that
Yeah.
they did back in Uber. He used to be at Uber when they built back when they built Jaeger, and it's a recurrent pattern. Uh,
Yeah. Tracing is currently like very, I would say it's like it's an underdog, I would say, of all the observability things, but I think it has a lot of potential. Like, I mean, I think tracing would replace like logs. Like from our use cases, we see that we think we can unify logs and traces under the same system.
That's
Uh,
actually a fascinating observation. I had a similar discussion several times in the past. Some people even asked me because I had a tweet about it in Twitter, and people asked, "How can it be that you can state something
yeah.
like replacing logs with traces?" But that I was actually part of a discussion that I had with an interesting startup. So for Slack, you actually switched over from logs to span data to traces, right?
So yeah, we write us at least not all of our log data, but we write some of our log. Like for example, our own mobile logs are actually emitted as spans,
Mm.
and all our traces are also emitted as spans. So we use the same ingestion pipeline, same analysis pipeline to process this data, and this actually simplified a lot of things in terms of like debugging, how we use the data quality of logging has actually improved because the same logs are used for multiple use cases. People are a little bit
Also more
careful about.
structured, so they
Yeah,
can get
logs are more
less lost.
structured. Yeah. Logs are more structured. I would say they're more semi-structured than structured because at the end of the day, you'll get semi-structured logs no matter what.
Yeah,
Because there is always like
a
log.info.
message or something that
Yeah,
is
exactly,
yes.
exactly. Yeah.
Yeah, and another thing that I think was interesting for me, because everyone is thinking, you mentioned that briefly before, that traces are in the context of a request or request response flow, but you also apply that for processes that are I don't know, off stream, that are not requests, that are driven by an event, like I don't know, a reboot of the operating system, things that don't
Exactly.
start
Yeah.
with an actual request, right?
Yeah. We actually apply tracing to our chef engine because so the biggest thing where traces are applicable that there is no good analog for elsewhere is causality. So what traces give you is, let's say you have a set of events, right? You don't know what event happened after what event today, right? Yeah, you can sort by timestamp, but if you have multiple threads doing things in parallel, that's not good. So what you do today is you take all these things, stick them in a storage like Elasticsearch or Splunk, and then manually reconstruct the order of events, right,
Yeah,
by in your head. But with tracing, all of that is done for you for free.
yeah.
And I think that's where a lot of value of tracing comes from. And that what our span event ad provides is provide causality between events, which actually helps you understand your systems better and apply it to model more higher level concepts like a business process flow or like a chef flow or things like that.
Yeah. So I think one of the things that really resonated with me, something that I've been saying for quite some time, also here on the podcast in many other stages, is that for me, observability is essentially data analytics problem. It's
Oh yeah.
getting data from many types, let's say signals, many
Mhm.
sources. It could be my front end app, my back end app. It could be my Kafka and my Redis and my MySQL and my AWS services and things like that, and meshing it all together, creating a conceptual data warehouse, and then being able to ask and answer whichever question I want to understand my system. That's
Mhm.
the mental model that I adopt, and I'm trying to get people away from the discussion on traces this and logs this and stuff like that. And I know that you've been preaching that from your end as well, and you've been analyzing that. So maybe you can share with us your mental model for observability.
Yeah, you're absolutely right. I think observability is a data problem, and today only like back-end engineers use it. Let's just face it. But I think even front-end engineers don't use it, right? So I think observability actually is a way to understand what's happening in your system, and it provides tools. The tools it provides are, hey, you can gather raw data, or you can gather pre-aggregated data,
Yeah,
right? And the raw data you gather would be logs, metrics, or traces or events, logs, traces, and events. And the pre-aggregated data would be metrics and profiles, right? And the way, like once you gather this data, what we do today is we stick them in custom databases and ask the question whenever we need to. But I think a better model for observability is to think about gathering pre-aggregated or raw data and then ingesting that data to suit your queries. For example, you can take the log data. If it's very structured and you're only running analytical queries on it, you'd stick it in the data warehouse or a columnar store.
yeah,
But if you're actually doing unstructured, if your logs are semi-structured, data warehouse is not going to solve your problem. So then you need to something like Elasticsearch. And if you're running, so there is a spectrum, and like what you use depends on what the ratio is, and there is no good answer anyways. Like sometimes you think this is the ratio, but when you actually go into an incident, you actually run string queries, right? Most of the time. So thinking about you can take your traces, put them in Elasticsearch store if you're running like search like queries, whereas similarly, or you can put it in a trace store to run trace like queries. So I think my mental model is you gather the data, and then depending on your read path, you would pick a storage engine. And once you do that, you can do that, and you don't have to just do that for just your backend logs or something. Once you start thinking like this, you can apply these ideas to front end systems, your business processes, and so on. Like even to some of the analytics use cases that people typically use. People don't even think of using observability systems for can be applied there.
Yeah, it's actually interesting because in last month's episode, on the January 2022 episode, I hosted the CTO and co-founder of Fronteg, and we actually discussed observability for SaaS businesses. And one of the things was that we discussed not just looking at the, let's say, IT observability, but actually look at much broader set of signals. It could be things coming off of your mix panel or amplitude.
Mm-hmm.
It could be things coming from your API observability service.
Mm-hmm.
It could be from many other sources to build a more comprehensive solution and observability that can serve to answer questions not just about the availability and performance of the underlying IT, but also about the functionality and performance of the actual features with
Mm-hmm.
predefined KPIs, success for the features, maybe for the entire startup, like the
Yeah.
onboarding of a bottom-up startup really builds on monitoring the users, freemium, converting them to paid, and all of that requires a lot of data analytics, which is another
Yeah.
type of observability, essentially.
Yeah, exactly. That's exactly how we think about it too, which is observability is not about like backend or logs or anything. Observability is knowing what is happening in your systems, whether it's a
Yeah.
business. Now, what can be a business process or like a low level operating system operation, or it can be like your logs or metrics. So,
Amazing, amazing. I think we're about to run out of time.
sure.
I would like to thank you for this discussion. It was fascinating, and to our audience, it's important for me to say we covered a lot of grounds here. That was very intense, but I will put a lot of references, both for the research papers that Suman mentioned, and for the videos, talks that he delivered, and about the Slack trace and the logging at Twitter, any resources that you can delve further and get more information. But I think the purpose here was to open up the minds beyond the traditional ways of thinking about the specific pillars, namely metrics, logs, and traces, also beyond the common open source tools. It doesn't have to be Elasticsearch or Prometheus or I don't know, Jaeger or OpenTelemetry. You need to find the right fit for your needs based on your patterns, based on your velocity, based on your volume and types of queries. So it's about better assessing the needs of the organization than finding the best need. Sometimes, as in this case, you may find yourselves needing to build your own. Not everyone is in the size of Slack and Twitter and everything, but some of them, especially the big web scale ones, actually need to be at the front, but hopefully also open sourcing it so that the rest of the world can follow the best practices and follow the open source way. So thanks a lot, and I would like to invite you to stay with me for the last part, which is a bit about breaking news.
Sure. Yeah.
And
And thanks for having me as well.
thank you very much. And before concluding and saying the last thank yous, I would like to mention several just very brief items, and fascinated to also get maybe your take on that. But first of all, we saw today, in the past week. Usually, I'm not concerned about specific vendors, but it's an interesting signal, I think, to the observability space in general. Cisco making a 20 billion plus offer takeover for Splunk. I think this is a very interesting testament to the interest in observability in this space, that a player such as Cisco is making such a massive investment, yet to be seen if it actually goes through. But as a signal, I think it's very valid, and also in terms of the direction that Cisco is taking towards this observability space. How do you view the move?
Yeah, I mean, it's definitely interesting that we are seeing finally, after years and years, seeing big numbers in the observability world, right? But I think this is just the start too, because like Datadogs and like Snowflakes are much bigger. I mean, Snowflake is also used for observability in some cases.
Yeah.
So I think this is just the start of the market, and these systems, like when compared to state of the art, are still like not the state of the art. So
I agree. I agree. And on the other side, on the open source side, I think one thing that was very interesting for me is the open source database company MariaDB that actually confirmed the plans to go public. That was interesting for me, both from the data store side, and I'm sure that you know very well MariaDB, but also on the open source side, because I've been into this discussion so many times in the past that I can't even remember about open source not being something that you can actually build a sustainable business around, and some actually didn't make it.
Yeah.
Like, I don't know, Elasticsearch that needed to pull Elasticsearch off of open source, the Elastic BV company, or things like that. But on the other end of the scale, there are companies that manage to create sustainable businesses while keeping the core product there, available to the community, serving the community, and not in conflict with the commercial interests of the company. So for me, it
Mhm.
was a very, very positive signal for the open source community. Did you follow this news piece?
Yeah, I am. I did. Actually, one of the interesting things that's happening is I think we are in the second golden age of databases. Like there was a golden age of databases in like the 80s and the 90s where there were like a lot of database companies. That's when like the Postgres, MySQL, Oracles, and like Green Plums and all of these came. And then there was a lot of lull in the there was nothing happening from 2000 to 2010 or even 2015. But I think now we are again in the golden age of databases where we are actually building databases for specific use cases now. MariaDB being one for the B-tree databases. There are like more storage engines for the columnar databases. We are seeing more observability databases. So yeah, I think again, like this is still early days of databases again.
Definitely, definitely. So I would like to thank you again, Suman, for joining me on this episode. It was a fascinating discussion, and looking forward once you release the information about CalDB and the follow up on the Mach as a POC or anything else. Do feel free
Sure.
to share it with the community here, because people will surely be fascinated to hear more about this effort.
Yeah, for sure. Thanks for having me on the show. And yeah, please follow me on Twitter and LinkedIn, and please send me your questions there. And also, we
Definitely.
are
You're
hiring.
at Mansu, right?
Yeah,
Mansu on Twitter.
yes, I am.
Any other way that you can be reached? By the way, for
Uh,
those who see on YouTube, you can see that on the screen, but also on the podcast. Any other way that you can be reached?
yeah, I can be reached at, you can reach my email account, suman.karumuri@gmail.com. And
Sounds
also,
good.
you can hit me up on LinkedIn.
Sounds good. So thank you very much, Suman, and thank you very much for the audience for staying with us on this discussion. All the episodes, as always, are available on your favorite podcast apps or on YouTube on the videocast format. We stream. If you're listening to this on a podcast, do know that we stream the episodes live on Twitch and YouTube Live, so you can actually join. Just follow us to see when the live stream takes place, and you can join the live stream so that you can ask questions and give your comments and take part of the discussion. You can find all the details about the Open Observability Talks at openobservability.io website, and feel free to follow us on Twitter at OpenObserve for updates or and to share comments, suggestions, news bits. Feel free to follow me as well at Horowitz for further updates around that. And if you want to be on the show, if you have something interesting to contribute, something interesting to share with the community, do submit a talk proposal. You can do that as well at openobservability.io on the CFP tab. And with that, thank you very much for listening. I'm Tutan Horwitz, and see you on next month's episode.